Hello friends, welcome back to my YouTube channel. Today in this video, I'll be continuing my discussion on distillation. This will be 23rd part of the discussion. And since last 4 videos, I have been discussing McCabe method. In my previous video, I discussed the operating line for stepping section in a typical train column. There I discussed what is the equation for the operating line of the stepping section and what is the effect of simplifying assumptions made in McCabe method on that equation. So in this video, I will be talking about how the operating line of stepping section intersects with the diagonal line. So the title that I have given to this discussion is Intersection of the Operating Line on the Stepping Section with the Diagonal Line. Okay, so let us start the discussion. First, we need to understand the distribution diagram, or what is diagonal line. We already know the stepping section line, operating line for the stepping section. Now let us first understand what is the meaning of diagonal line. So for that, we need to understand the distribution diagram, which is nothing but XY plot. So what is this? If you have a liquid solution of A and B in equilibrium with the Weber mixture of the same two components, A and B. And in this case, out of A and B, A is the more volatile component. That is, A has a lower boiling point and higher vapor pressure than B. X and Y, these are mole fractions. X is mole fraction of A in the liquid phase. Y is mole fraction of A in the vapor phase. Then, in this case, if the two phases, that is vapor and liquid phases, they are in equilibrium with each other, then concentrations of A in those phases, X in the liquid phase, Y in the vapor phase. So each XY pair, where when they are concentrations of A in liquid and vapor phases respectively, when they are in equilibrium, then each such XY pair, it defines one equilibrium state. Okay, so VLE data, which is nothing but vapor liquid equilibrium data, is then collection of many such pairs. So each pair in that VLE data will be defining a equilibrium state. Okay. Now the distribution diagram that we are talking about, the distribution diagram will then be obtained by plotting the VLE data. How is this data plotted? X is plotted on the x-axis and Y is plotted on the y-axis. So you already know this. I have discussed this in my earlier videos. So please visit my channel and see my earlier videos. So in this case, Y is plotted on y-axis, and X is plotted on x-axis. And you get a curve that is called equilibrium curve. And the diagram is called distribution diagram. Why it is called distribution diagram? Because this diagram tells you how components get distributed between the two phases, liquid and vapor phases, when they are in equilibrium with each other. That's why this diagram is called distribution diagram, or you call it as XY plot, or you call it as equilibrium diagram. XY plot because you are plotting X against Y. Equilibrium diagram because you are plotting equilibrium concentrations, equilibrium mole fractions. Okay, let us continue. So I already shown, I have already shown how the diagram is plotted. Now, as I said, X is plotted on X-axis. X is mole fraction of A in the liquid phase. That is mole fraction of more volatile component in the liquid phase. Y is mole fraction of A in the vapor phase. And this will be the diagonal for plotting. This will be the diagonal. This will be the equilibrium. This will be the equilibrium. Okay, that means if you consider any point on this curve, let us say this point, then this Y and this X, they will be in equilibrium with each other. They will be equilibrium concentrations. Okay, and this is the diagonal line, and this it. Okay, so our objective for this discussion is to find the point where the operating line for the stripping section is going to intersect with this diagonal line. That is our objective. So let us move ahead. Now let us get the intersection. That means we will be finding coordinates of the point where the two lines will be intersecting. So for that, we need to know the equation of the operating line. This was derived in my previous video. You please watch that video. Over here, I am directly taking that equation. So equation of the operating line for stripping section is this: Ym plus 1 is equal to L bar M divided by L bar M minus W into Xm minus W upon L bar M minus W into Xw. Let us call it as equation number 1. Then the equation of the diagonal line will be, since it is a square plot, that means the scale on two axes, same scale is used on both the axes. So the most convenient scale is on x-axis, you choose 1 centimeter is equal to 0.1 x, and on y-axis you choose again 1 centimeter is equal to 0.1 y. So if that is the case, it will be a square plot, and the diagonal that we are talking about, it will be diagonal of a square. So such a diagonal makes an angle of 45 degrees with the horizontal. Therefore, its slope will be 1. In that case, equation of the diagonal line will be Ym plus 1 is equal to Xm. Let us call this as equation 2. Okay. Now, in order to get the intersection point of these two lines, what should we do? We need to solve equation 1 and 2 simultaneously. And that is what we are going to do. Equation 1 and 2 must be solved simultaneously. So how to do that? For that, we will use equation 2 in equation 1. Equation 2 suggests that Ym plus 1 is Xn. So we will use this information in equation 1. Okay, so using equation 2 in equation 1, you get Xn is equal to L bar M upon L bar M minus W into Xm minus W upon L bar M minus W into Xw. So you must have noticed I have replaced Ym plus 1 with Xm. Okay, now let us simplify it further. So I need some space over here. I'll grab this. Give me 1 minute. Okay, take it. So what I have done in the next step, I have brought this term, the term containing Xm on one side. So that gives me Xm minus L bar M upon L bar M minus W into Xm. So this term, it was on this side, now it is on this side. That is equal to minus W upon L bar M minus W into Xw. So in the next step, if you look on the left hand side, xm can be taken as a common term out of this two. So it will be 1 minus L bar m upon L bar m minus W into xm. That is equal to minus W upon L bar m minus W into x2. Okay. So in order to understand this equation number 1, please watch my previous video. Okay. I'll give I'll give the link to that video in the description section. Okay. Next, I have simplified it further. So this will be L bar m minus W minus L bar m divided by L bar m minus W into xm. That is equal to minus W upon L bar m minus W into x2. Okay. So L bar m and L bar m, they are going to get cancelled, and you are left with minus W upon L bar m minus W into xm. That is equal to minus W upon L bar m minus W into x2. Okay, so in the next step, what can happen? You have the same term, a common term on both the sides, which is that term minus W upon L bar m minus W. And on this side also, you have the same term, minus W upon L bar m minus W. So in the next step, these two are going to get cancelled. So we have got this minus W upon L bar m minus W into xm, that is equal to minus W upon L bar m minus W into x2. So this term, it gets cancelled, and you are left with xm is equal to x2. Okay. Now, we are going to use this in equation 2. What is equation 2? Ym plus 1 is equal to xm. That means whatever is the value of xm, that is equal to yn plus 1. So over here, xm is xw. That means yn plus 1 is also equal to x2. Okay. So here, in the distribution diagram, on the distribution diagram, the suggestion is when you have the equilibrium curve, that you get after plotting x and y, and then if this is xm, this is y, so okay, and for the diagonal, intersection and the for finding intersection of the stripping section line with the diagonal line, we have obtained these two relations. One is xm is xw, and ym plus 1 is also xw. That means the diagonal line and the operating line, they are going to intersect with each other at this point. What is that point? Intersection point is xw, right? Are you understanding it? So when you are on the equilibrium curve, if you just go to this diagram, ym plus 1 is not equal to xl. But when you are on the diagonal line, since it is making an angle of 45 degrees, it will be having an equation of y is equal to x, equation of the diagonal line. So for diagonal line, it is yn plus 1 is equal to x. Are you understanding it? So that's why the intersection point for the operating line of the stripping section and diagonal line, it comes out to be xw, x2. I hope this is clear to you. When you are on the equilibrium curve, ym plus 1 is not equal to xl. But when you are on the diagonal line, these two are equal. Why? Because diagonal line is a line that makes an angle of 45 degrees. And that's why it passes through the origin, because it is a square plot. Therefore, its equation is y is equal to x. And we have used that information to get the intersection point. Okay, so operating line, just rub it. So operating line for the stripping section, we know the equation is ym plus 1 is equal to L bar m upon n bar m minus w into xm minus w upon L bar m minus w into xw. Slope is L bar m upon L bar m minus w, and intercept made by it on the y-axis is minus w, will be minus w upon L bar m minus w into x dx. So the intercept is minus, that means intercept will be on the negative y-axis. So the line could be like this. So this intercept is minus w for L bar m minus w into x dot. Okay, so for time being, I'll just tell you what is the intersection point. That is xw is xw. Okay, so on the next slide, you can show how the intersection occurs. So for that, again, I'm taking the distribution diagram. Now you have the diagonal line, and it is our conclusion that intersection of the two lines, diagonal line and operating line, it occurs at the point with coordinates xw, xw. Okay, so you locate xw on x-axis, go to the diagonal line, and if you go to the y-axis from this point will be, the y-coordinates of this point will be xw. And over here, the intersection of the two lines is going to occur. So stripping section line will be somewhat like this. Okay, we are going to understand more about how it intersects with the rectifying section line in future videos. I have discussed how to derive or what is the equation of operating line for rectifying section in one of my previous videos. So please go and watch that video. Okay, so over here at the end of the discussion, we have concluded that this operating line for the stripping section of a tray column, it intersects with the diagonal line at xw. Okay, so whenever you are doing analysis by using McCabe Thiele method, stripping section line will be intersecting the diagonal line at this point, or at a point whose coordinates are xw, xw. Okay, so y coordinate is xw and x coordinate is also xw. So I hope you have understood the concepts in today's discussion. If you have any doubt, if you have any questions, you please mention them in the comment section. For time being, for this video, thank you for being with me. Do watch my videos. Do subscribe to my channel. Tell your friends to subscribe to it. In my coming videos, I'll be talking more about McCabe Thiele method, and I'll continue discussing chemical engineering on this channel. Thank you for being with me. Do subscribe to my channel. Hit the bell icon so that you'll be notified as soon as I upload any new video on my channel. If you really like the video, or if you have any feedback regarding my videos, please give that in the comment section. Thank you, and hope to see you soon in my next video.